Alright, welcome back guys. Today we'll continue working on algebra problems. This time we're going to look at modulus, namely the absolute value of x plus 3 minus the absolute value of 2x minus 4 equals the absolute value of 5x plus 6 plus 7. So before we move on and talk about the solution, let's pause the video and think about it yourself. Give yourself a couple minutes. And don't forget to like and subscribe, and also try to share it to your friends. Are you guys ready? Good. So, first of all, when we have an equation of modulus, usually we will think of putting plus or minus sign to the term that is inside of the absolute value. And again, that's because of how we define the absolute value. At least for real numbers, that we will think either we will get a positive version when the term inside of the absolute value is already positive, or we will put a negative sign or multiply with the -1 to that whole term if the term itself is negative. So if we have an equation that contains more than one absolute value, for example, in this case, we have 3 absolute value signs. Then we will have 2 options for each term, meaning we have 2 here, 2 here, and 2 here. So there will be 8 options in total, or in other words, there will be 8 cases. Is it true? Do we really need all 8 cases? No. Here is the reason why. Instead of thinking of all the cases, we can actually do a little bit analysis, and we will see why we don't need all the cases. So first, let's label the 3 terms, 1, 2, and 3 respectively. So from the first term, we set absolute value of x plus 3. We know that this can be written in 2 different ways, either positive version or negative version. And when do we keep it as positive, and when do we need to multiply it with -1? Well, according to definition, we will keep it as positive if the whole term is greater than or equal to 0. In other words, we will just find out when the term is equal to 0, and that will give us where the cutoff point at, not equal sign. But if we find out, we will see that x equals -3 is where this term is turning down to 0. In other words, when x is greater than or equal to -3, we will have the term inside of the absolute value that's always positive. When x is less than -3, then we know that the term is negative, so we need to give a negative sign in front of the term. Or in other words, we need to multiply this by -1. Good. So if we follow this idea, we'll get that for number 1, there's a cutoff point at -3. For the second term, we have the cutoff point at +2. And for the third term, we have the cutoff point at -6/5, or -1.2 numerically. So now we are going to do the following. Let's make a table on the right hand side. I don't need this. So for the first row, we're gonna look at the x value, and then for the second row, this is too big. Here we go. For the second row, let's call it the y value, okay? Meaning the output of it. And you can also think it graphically, how these works. So let's take a look. If we call it y1, y2, and y3, then we can show the sign or the value of the first term, second term, and the third term respectively. So in fact, I should extend it a little bit like this. y2 and y3. Now recall that we found 3 different points such that one of the terms turns into 0. Now we're going to put these values in the first row in an increasing order. So we get -3 and then -6/5, which is same as -1.2, and also 2 here. And here is how it's going to look like. And then I'll put the dots here to represent the numbers in between. Okay, it could be any arbitrary number, but right now we only care about the sign. We don't care about the actual value, so it doesn't really matter. Let's see what's going on. For the first term, we say that when x equals -3, we'll get 0. So here we get 0. Now let's fill it in. For the second term, we have y equals 0 when x equals 2. For the third term, we will have a 0 in the middle. Great. So let's figure out what happened for other values. For example, if we pick a number, let's say -5, then for this value here, we of course know that we will get negative before we put the absolute sign. And then if we plug in any numbers bigger than -3, such as, let's say, -2, then we see that the value is already positive, and then it will continue being positive like this. Great. Next, if we do the same thing for the other 2 terms, we get the following. We get negative here and positive here. We get negative before the 0, and then everything is going to be positive after the 0. So what does that mean? It means that now we only need 4 cases. So let's see. Let me use this pen. We have case 1 right here, where here is the cutoff point, and then case 2 will be everything here as a cutoff. Case 3 be everything in between, and lastly we have case 4. How does that help? Here's what we're going to do. Now, if we consider case 1, case number 1, we see that for the first term, the second term, and the third term, they all will get the negative value inside of the absolute value. Meaning, if we need to rewrite the equation, we need to give a negative in front of every single term, such that we will get this. Got another negative. Then you put a bracket here. Equals, maybe I should use purple. Equals 5x plus 6, and then plus 7, and don't forget we need the negative sign, because we agree that all terms are negative before we take the absolute value. Okay, so if we take the absolute value, we'll get the negative of the inside. Good. Similarly, for case 2, we now see that for the first term, it is either 0 or positive already before we give the absolute value. So if we get rid of the absolute value, do we need to multiply with -1? Not anymore, because we are already having a positive value or non-negative value. However, for the other 2 terms, we still need to give a negative sign so that we will change the sign into positive. Like this. So with the similar arguments, we can get case 3 and case 4 for the with the following expressions. We now get Excuse me. This is negative. Right. For case 3, we only have the term, the second term still staying negative, but then for the third term, it turns into positive. Like this. And last but not least, we have the final case that all terms are being positive. Plus 4, no, minus 4. Perfect. So now we actually get all the cases that we need already. Instead of having 8 cases that we expected at the beginning, we only need 4 cases. You perhaps might ask, what happened to the other 4 cases? Well, the fact is, for the other 4 cases, we will not be able to get any solution that is valid. Those solutions will be outside of the range that we're expecting. Okay, and you can also try to check by substitute the value that we get into our original equation and see that the left hand side would not be equal to the right hand side. Why would that be the case? Because the charts that we have here is actually following from the graph that we will have if we put these 3 terms into 3 different functions, so that we will be able to visualize it with the graph. Therefore, in this case, we see that it's not necessary to always just consider putting plus or minus sign in front and then to split into all different cases. It will be faster if we can just consider the order of what we call the critical points. And again, if you don't know what a critical point is, I shouldn't say critical point. It's actually more precisely is it's called a local minimum or local maximum. But if you don't know what it is, I'll find another video to talk about it. Is an idea in calculus or something higher. So anyway, now we actually can save half of the time because we only have 4 cases instead of 8 cases, and we will be able to get all the answers we need. Of course, at the end, after we calculate each case, we still need to check whether the solutions are valid or not. We need to verify all those answers. And I'll pause this video right here because the rest are just simply algebras that I believe everyone can do it, and you can figure out how to do the rest by yourself. In this video, I'm trying to give you guys another thoughts that how we can analyze the problem to save us time and also, of course, getting it correct without actually doing what's so-called a general way, but with a lot of cases that we probably don't even give us anything. Okay, so it is kind of like a shortcut or a small trick that you can use, like for example, if you're like when you see these kinds of problems on the exam. But yeah, for the basic things that you already learned in school, such as how to solve a linear equation like this, I believe you all have the ability. Well, you all have, yeah, you're able to do it yourself. So I'm not going to continue from here. That's it. Thank you for watching. I'll see you guys next time.